We're going to start off on page 3 with the limit definition of the derivative, the difference quotient. What I want to go over is the idea of the limit definition of the derivative using this thing called the difference quotient. The first thing I want to do is label this as just some random x value. So this coordinate here is actually going to be x, comma, f of x. Because that's what I'm calling the name of my curve. I'm calling this curve f of x. And that's just the name of my curve. And now I want to go over here to this point. Now I moved some distance over to here. So I'm going to call that distance from here to here, that length I'm going to call h. So this coordinate here is x plus h. Because if this were 5 and this were 4, this would be 5 plus 4. And then this coordinate is actually going to be x plus h for my x value, comma, f of x plus h. Now what I want to do is find the slope of that line, going through x, f of x, my xy value, and my x sub 2, my y sub 2, my x plus h, and my f of x plus h value. So this is my x value and my y value. And as you recall, that formula I believe was y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to set that up, and I'm going to label this as my 1s. This will be my x1 and my y1. And this will be my x sub 2 and my y sub 2. And I just want to set up my slope formula between these two coordinates. So it looks like it's going to be y sub 2, which is f of x plus h, minus y sub 1, which is just f of x, all over my x sub 2 coordinate, x plus h, minus this coordinate, just plain old x. Now if I do a little arithmetic on the bottom, I'll get a new formula that looks like this. F of x plus h minus f of x all over, and notice the x's will cancel out, h. And this has some significance if I let h, this distance, get smaller and smaller. If I let h get smaller and smaller, that's going to bring in something we call a limit. And we're going to say as h approaches 0. Now as we do that, we work closer and closer to something called the derivative. Now let's go back and take a note. This original difference quotient was the slope of a line between 2 points. And in calculus, we call that the average rate of change. Now this limit, as h goes to 0, of the slope over h is the derivative. And that is the slope at a singular point anywhere on this graph. But I chose it to get closer and closer to x in this case. And that's what we call the instantaneous rate of change. Average rate of change is a secant line. The instantaneous rate of change is a tangent line.